Thank you. And more generally, thanks to Jeff and Clara for organizing this great event, and to Clara also for inviting me to speak when, unfortunately, Stephen Harrop wasn't able to make it. That may not give me a total excuse for the nature of this talk, which is maybe a bit more exploratory. It's less of a finished paper than some of the other talks here, but I'll plead sort of the lateness of my coming to be part of this conference as an excuse. Okay, so today I'll be talking about some remarks on magnitudes and related topics that are found in the early manuscripts of Du Châtelet's Institutions de Physique, and I'll also try to set them in the context of Leibniz and Wolff. The published Institution is concerned with the foundations of mathematical physics, but it says less than one might like about the status of mathematics. So this is one reason why I'll be talking about manuscripts. Another reason is just that, to my knowledge, no one has really discussed these particular manuscript passages, but correct me if I'm wrong about that. So I want to first say a bit more about this manuscript, which is in its physical form at the BNF in Paris, and it's therefore standardly called the Paris manuscript of the Institution. And Hans-Peter Neumann, Jill Muller, and I are producing an online critical edition of this manuscript, which is gradually appearing online at historyofwomenphilosophers.org. Here you can see the current version, though it doesn't yet contain all of the textual information and commentary that we're planning to add eventually. Du Châtelet worked extensively on the Institution from 1738 to 1740 and revised it a great deal. The manuscript is much longer than the published work, and this presents a question about how to regard discussions that appear in the manuscript and seem consistent with her published views, but don't appear in the published version. My impression from working on the manuscript is that some of the omissions are due to caution or desire to avoid undue controversy or even to length constraints, and perhaps the manuscripts can sometimes give us a more direct and unvarnished look at what Du Châtelet thought on certain topics. The manuscript passages I will discuss a bit later do not appear in the published Institution, but Du Châtelet never cancels them out in the extant manuscripts. And I don't think they contradict the published texts. Of course, this leaves quite a bit of room for debate about whether they're her final view, though we do know that they come quite late in the approximately 3 or 4, maybe, year period that she was working on these manuscripts. A standard practice in the literature has been to consider unpublished chapters from the Institution as worth discussing, notably her chapter on freedom that was apparently written in the 1730s, but does not appear in the final version. Now, the placement of these discussions of magnitude is of particular interest. For, first of all, a pair of definitions of magnitude and related concepts appear in late drafts of the first chapter, a chapter dealing with first principles of knowledge and principles of our chains of reasoning, or raisonnement. But another very similar discussion can be found in the drafts of the final chapter, which is on the force of bodies. Now, this discussion is on a loose sheet, and its exact placement is not easy to recognize. You can see some tiny comments there from an archivist saying that they're not easy to recognize, and where it goes at least. And this suggests still that Châtelet may have planned to incorporate these ideas on magnitude into her discussion of vis viva and related topics at the end of the Institution. And speculatively, of course, this could be because her discussion of vis viva essentially involves infinitesimals, infinitely small speeds and times and so on, that somehow are supposed to add up to finite and measurable effects. She holds, as Leibniz also does, I think, that a finite change is to infinitesimal impulses as a line is to a point. But a standard assumption at the time was that points could never sum to a line. For example, Pierre Bayle commented that persons of the slightest depth can comprehend this with complete certainty. So she may have contemplated an excursion into the metaphysics of quantity in order to justify summing infinitesimals into Archimedean quantities that are finite. Now, to provide even more context on why I'm interested in this, I have a forthcoming chapter that tries to explain a couple of important things Du Châtelet says about mathematics, which might seem to be in tension with one another. On the one hand, she says that some or all mathematical objects are fictions. But she holds, on the other hand, that there is a very close correspondence between nature and geometry, and even between nature and calculus, because she thinks calculus is the geometry of the infinite, and just as certain as Euclidean geometry. Now, nothing seems to force typical literary fictions to correspond closely to nature. And in my view, Du Châtelet is using the term fiction in a broad sense, one that covers many sorts of abstract artifacts and allows for important disanalogies with literary examples. But this still leaves the question of what explains the supposedly reliable correspondence between mathematical objects and what happens in nature. And perhaps her account of magnitude could shed light on this. So I will eventually come back to these three theses articulated in the manuscript, but I'm just putting them up now as a preview. So first, that magnitudes per se are internal properties of concrete material things. Second, that fully understanding a magnitude, apparently such that things are grasped as having a size that falls under some particular type or kind, that this requires comparison among things. Finally, a further condition is added for communicating a magnitude to someone, namely that it must be related to a known unit of measure. Yeah. So before looking, though, more closely at Du Châtelet's manuscripts, I want to look back to some ideas in Leibniz about the status of magnitudes, because these were important for post-Leibnizian rationalists such as Wolff and Baumgarten, and they at least provide a helpful point of comparison for Du Châtelet as well. Here's some quotes. In a piece on analysis situs from the early 1780s, Leibniz writes, "Those things are similar, which cannot be distinguished when observed individually. Quantity can be graphed only when the things are actually present together or when some intervening thing can be applied to both. Quality represents something to the mind which can be known in things separately and can then be applied to the comparison of two things without actually bringing the two together either immediately or through the mediation of a third object as a measure." Now, this is not just a one-off remark. For example, similar ideas appear in the 1715 Metaphysical Foundations of Mathematics, and they are already in place early on, or even earlier on, as a draft of a letter to Galois reveals further down on the page. I guess I'll read this one as well. So Leibniz writes, "I have found that two things are perfectly similar when they cannot be distinguished except by compresence. For example, two unequal circles of the same matter cannot be distinguished except by seeing them together, for then you will see that one is bigger than the other. You might say, I will measure one today and the other tomorrow, but I maintain that this is still to distinguish them not by memory, but by compresence, because you have the measure of the first one present not in your memory, for magnitudes cannot be retained in memory. Then the material measure engraved in a ruler is some other thing. For if all the things in the world affecting us were diminished in the same proportion, it is evident that not a single person would notice the change." So a lot going on here. These passages could be read in a relatively deflationary way, I should note. On a more deflationary reading like this, Leibniz would merely be talking about necessary conditions for how we distinguish or grasp quantity and quality. It would be a further step to say that these necessary conditions for knowing about quantities and qualities really track the natures of these kinds of properties. So I don't want to venture too deep into the waters of Leibniz's interpretation, but I do want to note that at least some leading scholars don't adopt such a deflationary reading. They instead take these passages to offer at least partial definitions of quantity and quality, and not just to make some epistemological points about how we distinguish or grasp them. And this is interesting to me because it might be, and I want to suggest that Wolff and other post-Leibnizians may have read Leibniz in this more metaphysical way. So for example, Vincenzo de Risi, in his work on Leibniz's analysis situs, argues that these passages give a definition of quantity, though perhaps this is a negative definition, and perhaps it depends on Leibniz's definition of similarity. As de Risi notes, and you can see here as well, I won't read all these passages, but Leibniz uses similar language of coordinated co-perceptions in some of his definitions of extension, as in the remarks seen here, in the letter from, the remarks on a letter from de Bos, who, incidentally, was writing to Leibniz from Paderborn, so we have a local connection with this quote. Richard Arthur, in a recent book, straightforwardly takes these passages to suffice to distinguish qualities and quantities. And I think it's also worth adding, and Derisi also points this out, that this account that Leibniz is offering should not be confused with the claim about the conventional character just of units of measure. So that sort of trivial semantic conventionalism is a fact about our concepts of language, and Leibniz's account of quantity seems to be more metaphysical. And in fact, on Derisi's view, this account of quantity flows from Leibniz's metaphysics of space and time. As I briefly noted, Du Châtelet herself seems to distinguish more metaphysical questions about quantity from further practical issues of measurements, and I'll discuss her views on this more in a moment. Now, to unpack the possible implications of this Leibnizian view a bit further, consider that if qualities can be grasped in individual things without comparison, and quantities require comparison between at least two things, then qualities start to look like intrinsic properties and quantities like external and relational properties. As Daniel Sutherland has noted, this would seem to entail that magnitude is not an inner or intrinsic determination of any thing. So now, on this reading at least, two similar triangles will differ only in quantity in virtue of their relations, either to one another or to some common measure. They won't differ due to their intrinsic properties. And likewise, equal triangles in themselves will not have any quantitative properties in common that unequal triangles lack. They just happen to have certain relations. Now, to be sure, if Leibniz were just adopting any sort of relationalism about quantities, it may not be clear why his successors would worry about his view. For relationalism about quantities is similar to relationalism about space and time. And Leibniz is, I think, a relationalist about space and time, and his position is usually considered coherent, even if it may have some odd consequences. Likewise, a relationalist or comparativist view about quantity seems quite coherent, even if it entails some counterintuitive consequences. And today, structuralism or relationalism about quantities is defended as a live option in metaphysics, for example, by Shamik Dasgupta in the paper mentioned here. But not all relational accounts are created equal. And in particular, it might be problematic if Leibniz is appealing here to relations of actual co-presence among things. At the very least, that would seem to be parasitic on actual contingent spatial relations between bodies. And his account also seems to invoke presence to an actual observing subject, which threatens to bring in subjective psychological criteria for magnitude. If all magnitudes depend on actual co-presence relations which continually change, it may be hard to see how we could ever objectively define magnitudes, such as equal distances in times in physics, or equal lengths, areas, and volumes in geometry. Without these fundamental relations of equality, it would look very hard to do physics and geometry as we know them. So we can consider a simple geometrical example. We have two line segments from A to B, and from A prime to B prime, that look to be congruent to one another. But how do we show this rigorously? So Euclidean geometry, you probably all know, uses a straight edge and not a ruler in the sense that it doesn't mention distances. In fact, Euclid does not define congruence either, but his proofs do display a well-known method for determining congruence for plane figures, namely the method of coincidence or superposition. Basically, two figures coincide when one of them can be moved to fit exactly on the other. Unfortunately, this appeal to superimposition raises well-known problems. For one thing, it seems to bring motion into geometry. And worse, the can it invokes seems to rely on mere intuition and needs to be argued for. Why should we assume that all equal line segments can coincide? And why should we take for granted that a line can be moved rigidly or without deformation? So modern geometry, partially for these reasons, tends to avoid any appeal to superimposition or coincidence. One option would be to just take facts about congruence as axioms, like Hilbert does. But more commonly, people use set theory and abstract algebra to define points as ordered pairs and get a distance function from point to point. And then you can define congruence for segments in terms of equality of distance. You can also use this metric approach to go back and give an account of why superimposition would be a criterion for congruence, like this Euclidean intuition. But that happens, or that works once again in terms of a distance-preserving function that relies on this algebraic structure and not on particular motions and coincidences, as you can see in the diagram at the bottom right. The point here, though, is just that the Leibnizian passages we've discussed seem to presuppose the older Euclidean method of superimposition and coincidence. In fact, they may go even further, since for Leibniz, if he's read a certain way, there would be no intrinsic facts about the length of AB or A prime B prime apart from actual procedures of superimposition, whereas Euclidean geometry does not rule out such intrinsic facts, it's just silent about them. So it might be that the method of superimposition would be even more fundamental in Leibniz than it was in Euclid, but it's still not so clear why it actually works. Vincenzo de Ricci, in fact, takes these passages to commit Leibniz to the strong dependence of geometry on synthesizing operations carried out by finite minds. And geometry then acquires its objectivity more from the mind than from properties of figures as such. And this could be supported by texts such as the one in the New Essays, where Leibniz alleges that even for material things, quote, the only perfect unity that entities by aggregation have is a mental one, and consequently their very way of being is in a way mental, and so on, unquote. Of course, there are various other ways to read Leibniz, as always. He has resources, for example, to move towards a more metric approach, perhaps, by grounding geometry in points and their situs relations, maybe ultimately in non-geometrical facts about number and order. He also has suggestive remarks about invariances preserved across continuous transformations of figures, independent of these kinds of particular coincidences. And in a much more traditional vein, he also sometimes suggests that geometrical truths are grounded in the divine intellect, quite independently of any operations of our minds. But I'm going to leave all those difficult issues aside, those options, because what I really want to consider is the legacy of these Leibnizian ideas. So what I would say here is that later rationalist thinkers, some of them at least, wanted to take up Leibniz's suggestion that quantity is based in comparison in some important way, but they wanted to reject any possible sort of metaphysical theses about relationalism here, for better or worse. Leibniz's remarks on quantity were mostly unpublished, but he did share them with Wolff in correspondence. And both de Ricci and Sutherland have noted, or respectively they noted, that partly Leibnizian accounts of quantity seem to pop up in Christian Wolff and Alexander Baumgarten, as you can see in these quotes. So Wolff, like Leibniz, says we can only distinguish similar things by placing them side by side, and that quantity is not among those things by which we recognize and distinguish between beings. This might just be epistemic, however, as Wolff repeatedly says that quantity amounts to an inner difference among things and not just an external relation. So to read out this whole passage, Wolff writes in German Metaphysics, although magnitude is indeed an internal difference, it cannot be reckoned among those things by means of which one cognizes and distinguishes things, because it cannot be comprehended as such by the understanding, but rather is only given, and thus must be grasped merely by the senses. I will say a bit more about Wolff's position later. To me, it seems somewhat unstable. By contrast, I think Baumgarten, writing quite a bit later, is consistent at least. So this is his discussion of quantity in his own Metaphysics, which is published well after Du Châtelet's Institution, by the way, but is still influenced by Leibniz, it seems. So Baumgarten writes, the internal distinguishing marks can be represented as being considered in itself, and hence can be known in some way or given. We can either conceive of and understand, that is, know distinctly given things without assuming or relating them to anything else, without the presence of anything else, or we cannot. If the first, then such an inner determination of a thing is a property or quality, qualitas of the thing. If the second, it is a magnitude. That's quite a mouthful, but the basic idea is that for Baumgarten, there really are these intrinsic quantitative properties in things which seem to be absolute in some way. But we only represent these indistinctly when we consider a single thing. We need to compare many things to distinctly cognize or know quantitative properties. But we don't have to do that for qualitative properties. This move allows Baumgarten to reinterpret Leibniz's emphasis on comparison in a basically epistemic way. So I say here that both Baumgarten and Wolff seem to go epistemic on this issue in some important sense. And this brings us back finally to Du Châtelet's manuscript. So first, let me discuss a key metaphysical claim she seems to make, which is that magnitude is a determination or property that's internal to a thing. This seems to track Wolff's earlier discussion as well as the later account in Baumgarten. But Du Châtelet's point seems to apply in the first instance to concrete things. The example she gives is particles of matter. And she stresses that two concrete things can be qualitatively identical and really differ in virtue of their magnitude. This seems to be not just an epistemic point about how we tell things apart, but what underlies our ability to tell them apart is a real metaphysical difference in quantity. This is something like a metaphysical ground of individuation. And that would make sense, I think, given her view here at least, is that magnitude is a property internal to concrete things. The case she discusses, once again, is two particles of matter with all their qualities and structural features in common, but different volumes. I here have a slightly silly illustration of two white phosphorus molecules that are of different size. I've made them that way. Silly though it might be, in section 66 of the German Metaphysics, Wolff talks about a very similar sort of case where the parts of a composite being can be enlarged, as he puts it, without their order or qualitative properties changing. So the point seems to be something like, as in geometry, roughly as in geometry, the particles have a certain structural configuration which would be preserved across differences in size. Now, I want to say a bit more about this Du Châtelet's thesis that magnitudes are internal to things, put it into context a bit, I guess, because I think in the context of her broader views, it's rather complicated. So I don't think she can mean here that magnitudes are absolutely intrinsic to material things, because material things and their magnitudes are partly mind-dependent given her idealism. Therefore, there are no possible worlds that contain material things and their magnitudes, but no souls or minds. If magnitudes were absolutely intrinsic properties, there would be such possible worlds. So we can conclude, I think, that magnitudes are not absolutely intrinsic properties. Nevertheless, material things are less mind-dependent than fictions, dreams, or even maybe mathematical objects per se. And so I think Du Châtelet can draw here on the Leibnizian idea that phenomena can be more or less well-founded, so that even if material things lack absolutely intrinsic properties, we can distinguish between their comparatively intrinsic properties like active and passive force, and more purely relational properties such as location, which maybe that's not even relational, it's just an abstraction. I want to also note a few differences and similarities with Wolff's brand of idealism, if he has one. So Wolff takes extension and continuity in bodies to be something like secondary qualities, based in mere confused perception of simple substances. On his view, if we grant that extension is real, spinozism is inevitable, as he says, quote here, roughly because it would make God essentially extended, this view. So for Wolff, the extension of bodies is partly mind-dependent, and this means that a length will not be intrinsic to a body. There are only lengths in worlds where minds can have confused perceptions. Wolff and Du Châtelet might diverge, I think, when it comes to the metaphysical status of force. For at least some of the time, Wolff presents composite bodies as only having extension and motion, not really force of any kind. So, at least in some passages, it's only the simple substances underlying them that properly have force for Wolff. This allows Wolff in his more polemical moods to dismiss Newtonian forces as occult or merely imaginary qualities. As Catherine Dunlop has shown, this critique is linked to Wolff's line that Newtonian force, along with his absolute space and time, are merely mathematical concepts and not part of genuine causal metaphysics. Du Châtelet, meanwhile, seems ready to accept force in bodies as real, though non-fundamental, as something like a well-founded phenomenon that is partly mind-dependent and partly mind-independent. Now, Wolff can also talk this way in more conciliatory moods when he's not being so metaphysically strict. In general, though, I think Du Châtelet is more willing than Wolff to grant the non-mathematical reality of forces as properties of bodies and not just of simple substances. Relatedly, she's more optimistic than Wolff is about mathematical representations of the world. For Wolff, does not think mathematics is even properly part of the domain of philosophy. It studies imaginary rather than real things. Now I want to say a bit more about Du Châtelet's statements that, quote, there is a great difference between similar and equal, that a quality has magnitude for its object, and that two things can be called equal when one thing can be put in the place of the other and everything remains the same with respect to quantity. The basic distinction here is rather traditional, and Aristotle already held something like this. That can be seen in the quote, that things are similar when their quality is 1, but equal when their quantity is 1. Later, Kant picks up similar ideas, but we can talk about that in Q&A if you want. There's also some language in this quotation from Du Châtelet that echoes Leibniz or Euclid. Equality obtains when one thing can be put in place of the other and everything remains the same with respect to quantity. A first problem here seems to be, for Du Châtelet at least, that this is more apt as a definition of congruence, not equality. Figures, it seems like, can be equal but incongruent, as Kant often pointed out. And another problem might seem to be that this calls into question the idea that magnitudes are really internal to concrete things, because equality of magnitude now seems to depend on relations of co-presence. In fact, I think she can diffuse these problems because I think she takes magnitudes in concrete things, because I take her to be pursuing a roughly similar strategy to Wolff and after her Baumgarten, in that magnitudes can only be fully grasped through comparison, but they genuinely are in concrete things. There's some textual support for this. Magnitudes are in things, and are internal grounds of real differences between things, but as she puts it, they can only be understood or apperceived by comparison between objects. Now, one way to understand this point would be to appeal to some kind of type token distinction, so that token magnitudes are just in material things, but magnitude types are more relative to concepts into a comparison class, such as a class of lengths. A related way of putting the point would be that we have some grasp of magnitudes, for example in perception, without being able to determinately answer the question, how big is this magnitude, or what is its size? And for that we might need comparison through the understanding. We can thus see Du Châtelet as taking on the epistemic aspects of Leibniz's points when it comes to grasping size in a general way, but still holding that token magnitudes themselves are in material things and not just external relations. So as Frege later emphasized, much later, in his Foundations of Arithmetic, counting seems to be relative to certain kinds of sortal concepts. One of his examples is that if I asked you to find the number of a deck of cards, the answer seems to be underdetermined. It might be 1 deck, or 4 suits, or 52 cards, etc. So it might be that integers are intuitively more like sizes than they are like concrete token magnitudes. I think there are, in fact, many textual indications that for Du Châtelet, the integers are not identical to token magnitudes. As we've seen already from some other talks, numbers are partly dependent, she thinks, on things numbered, but their existence also depends on an active power to form mathematical objects through abstraction. While matter and its properties are partly mind-dependent, she does not describe them as ideal, abstract, or fictional, and this makes sense because token magnitudes are properties of concrete things, and numbers are not properties of concrete things. Magnitudes per se, it seems, are not the objects of pure mathematics. It's noteworthy that in the manuscript she stresses this account of magnitude is especially apt for algebra, and it would be odd if she thought that token concrete magnitudes are especially apt objects for algebra. Her account of algebra is that it speaks only to the understanding, as she puts it, because its objects cannot be represented in images. Presumably, algebra works at the level of sizes and magnitude types that arise from comparison and only indirectly applies to token concrete magnitudes. As Descartes, Wallace, Leibniz, and others have argued, algebra relates magnitudes of many kinds, whether continuous or discrete. By contrast, I don't think Wolff gives a very clear account of algebra, and instead employs a more traditional Euclidean approach to forces, on which they must be treated as composed of homogeneous parts. So there's an important difference here, I think, between the philosophy of mathematics, as it were, of Du Châtelet and Wolff. So one last topic, rather quickly, will be what Du Châtelet says about what we might call the pragmatics of magnitude. And it's here that we finally get a reference to units of magnitude, because she says that to communicate a magnitude is to someone successfully means using units that person knows. Now, this need not be a purely conventional unit, because she considers cases like telling someone that 2 of one triangle would fit in another, where there's no need to indicate a further unit of measure. In any case, there are some similarities here to a view expressed by Wolff. So he writes that, quote, if I'm supposed to tell someone how large something is, I must tell him what relation it has to a certain measure that he's familiar with. It's interesting, though, that Wolff uses that point about communication to draw the previously mentioned conclusion, it came up in a quote, that a measure must be sensibly given for a magnitude to be fully grasped by an agent. So I don't think Du Châtelet ever explicitly draws this epistemological conclusion about the sensible givenness of a magnitude. Here in this discussion, she's primarily interested in communication or understanding rather than the very possibility of grasping or understanding a magnitude. As a little aside, this is a very rich, interesting issue, in part because Kant can later be seen as radicalizing the epistemic requirement that Wolff is gesturing at. So for Kant later, the very identity of a mathematical quantity depends on a given form of sensibility because we cannot distinguish between two homogeneous units by concepts alone, or so he thinks. Numerically differentiating magnitudes of the same species, Kant thinks, requires space and time. Nevertheless, Kant explicitly rejects Wolff's and Baumgarten's suggestions that prior to comparison, magnitude is non-conceptual or non-cognitive representation. He, at least in a lecture, Kant reportedly says that this sensory definition of magnitude that he finds in Wolff and Baumgarten can never be valid. End of aside, let's return to Du Châtelet. While much more could be said about the sort of pragmatics of magnitude, I want to draw just one last connection to the treatment of units of measurement in the published Institution. So she thinks, as has come up also in the conference so far, that most units are conventional in some sense, but it doesn't follow that magnitudes as perceived or understood are conventional. She also distinguishes the element of conventionality in measurement from questions about the accuracy of measurements. The accuracy of a method of measurement is not a matter of convention. For example, a sundial is not a very accurate measure of time, whereas a good pendulum gives what she calls true time. She actually uses the phrase absolute and true time in the manuscripts, where she might have in mind an ideal pendulum that wouldn't be subject to drag and so forth. So in conclusion, let me come back to some issues I flagged at the beginning of the talk. So first there's the question that's sort of more internal to the Châtelet system, which is why do mathematical objects correspond to what happens in nature if these mathematical objects are fictional? Her account of magnitude might partially answer this question. Mathematical objects such as numbers or geometrical shapes are abstracted from and counterfactually depend on magnitudes in concrete things. In her words, actual abstract entities cannot subsist without concrete entities, or an abstract peut subsister sans un concret. She also talks, though, about merely possible numbers, and the story for them would have to be different, but of course, I'm going to have to leave that aside today. Anyway, her account of concrete magnitudes might help us see why mathematics and nature correspond. For material nature and mathematical objects are both partly grounded in our distinctive faculties of cognition, which seem to somehow spread things out in space and time. So lastly, though, there's this more contextual question that arises from some of Leibniz's writings, a question that seems to have worried both Wolff and Baumgarten. The question is, how can an account of magnitude retain a role for comparison without dissolving magnitudes into mere external relations? On the one hand, Leibniz and Frege seem to be right that counting, or saying how big something is, requires a comparison class and can't be answered in a vacuum. But there's also something counterintuitive about denying that things have internal quantitative properties, especially if the alternative appeals to mere relations of actual co-presence in a particular subject's perception. So maybe Du Châtelet can get the best of both worlds here, where there are both token, concrete magnitudes in things that we can perceive, and also more cognitively laden mathematical objects that we understand and which depend on comparison and abstraction. So I would say that her views, though they might be influenced to some degree by Wolff and indirectly by Leibniz, carve out a very distinct and interesting position. Thank you.